Chromebooks out, opened up the classroom. Specifically our page. Just so you don't have to copy, feel like you have to copy all the topics on the test tomorrow. They're up on Classroom right now under Unit 7. All right, you'll see test topics on there under Unit 7. That's what I'm showing right up on the screen right now. How you want to take extra notes, that's on you. Okay, but everything's there right now. 35 points. Please don't get a big head if you did well on the similar triangles quiz. This is a little bit more extra. All right, the extra being mid-segments and product of the means equals product of the extremes. That's added on to what was on your quiz. So let's go over everything real quick. I want to make sure we're all clear about what to expect. The 35 points, we're good there. All right, if I give you two similar triangles, can you set up a proportion and solve it? All right, can you match up corresponding sides correctly? I know we've gotten a lot of practice at that. More coming tomorrow. Mid-segments, we went over this on Friday. That's why I'm not starting with the homework today, because I know everybody finished it, and if you had questions, you would have asked at that time. Quickly on mid-segments. I got triangle ABC. Now, a mid-segment can't be any random line segment drawn in. It has to be connected by what of the two sides? A mid-segment is connected by the what of two sides? What are these here? Midpoints. They have to be midpoints. It just can't be two random points connected together. It's got to be the midpoints. All right, so DE is a mid-segment. Two things you should know about DE. I'll turn it over to you. If you have to look back in your notes from Friday. What should I know about DE? Two things we should know because it's a mid-segment. 19, start us off. What do I know about DE?
It's parallel to BC.
Good, parallel to the third side. And remember, the third side is the side that's not connecting it, which, yep, is correct. DE and BC are parallel. What else do I know about DE? Yes, it's parallel to the third side. And 17.
BC.
Half the third side, in this case, BC, correct. All right. So if I was going to put this on here, 7, 14. Half the third side. All good? Next, 3 ways to prove triangles similar. Let's review. What do you got for me? 3 ways to prove triangles similar. One way. 17. Actually, let's hear from some other people. 14. Way to prove triangles similar. We have a 14 or no? I guess not, huh? Should have every other number then. 20. How do we not have a 14 and a 20? That's almost impossible.
20 is not here.
Then we don't have a 14 in general?
I think that is
Okay. I just happened to pick 23. Angle, don't need the third A. All right, angle. And also the way you're going to do it on a proof. Other 2, not in the proof, but still valuable. Ooh, not doing it again. 17. Side angle, side. Similarity. Got to know the sides are what? Not congruent, but in the same ratio. In the same ratio, right? Those 2 pairs of sides. And the third method. 9. Side. Again, all 3 pairs of sides are in the same ratio. All good. Factoring, quadratic formula. I really busted your chops on the quiz on this. Not so much here. There's only going to be one of these problems. Okay, where you have to use quadratic formula or factor. I'm not going to tell you which one, though. All right, only one of those tomorrow. All right, because I really got after it on the quiz with it. What I am going to get after, though, because this is the last time you'll see these for another couple of units, is the proofs. All right. I think you had a very easy time on the proofs on your quiz. Not this time around. Okay, they're going to be a lot more difficult. And I just wanted to give you a heads up. Probably both of them, you're going to end up with means and extremes at the end. My worry is how you get there. All right, how you get there. Remember, it's a 3-step process. First step, you got to prove the triangle similar by angle, angle. All right, that's your first job tomorrow. Take these two triangles, prove them similar by angle, angle. And this is why I'm saying it's tough tomorrow. You may get that one pretty easily. You're going to have to dig pretty darn deep tomorrow to get the second angle. All right, it's not going to be impossible. You have more than enough knowledge, but it's going to be honors level getting that second angle tomorrow. Both proofs, both. All right, what happens when you get both pair of angles and you prove them similar? What's next? Not means and extremes. You're not ready yet. What comes in between? Yes, CSSTP, but what are you writing for CSSTP? What is true? What's your statement because of CSSTP? This is why we're going over it. You got the triangle similar by angle, angle. What's true by CSSTP now? Oh boy. Go ahead, Serena.
The sides are similar.
The side, don't say similar. Sides can't be similar. They're in a ratio. So look, I'm just making this up. AB over BC equals DE over EF by CSSTP. Then finally, you get to AB times EF equals BC times DE by product of the means equals product of the extremes. It is a 3-step process at the end. Okay? You better have both angles, though, before you start this process. Because never mind, I'm not even going to tell you what usually I get kids to do incorrectly because I don't want to mess with your mind. But that's it right there. Questions from you guys? Going. All right, I have 3 examples. Oh, sorry, go ahead, Eva. Sorry.
Are you going to give us the quadratic?
I absolutely will. That's never going to change. You will always have it if you need it. Yep. Anything else? I got 3 questions I want to do from the review packet. And then I'm going to let you go on your own. Get to day 7 review. Some of you guys started these on Friday. All right, get to page 34 for me. And just so we're completely on the same page, literally, on page 34, you have review questions, and you have the textbook questions to try on the top. All the answers in the back of your packet. The only thing I'm not offering this unit that I usually do is an extra review on Classroom. This is all you need right here. Okay, so packet work and textbook work. All right, that's what I have for you. Everyone look at number 3. If you didn't get to it Friday, good. If you did, just hop along here with us. All right, number 3. The 2 triangles are similar. And I know a few side lengths. AC is 12, DC 7, DE 5. And I'm giving a little extra info. Perimeter of the big triangle is 30. How about the perimeter of DEC, the smaller one? One big thing I tried to push this unit, if the 2 triangles are similar, which they are, perimeter ratio is always equal to what? Perimeters are always in the same ratio as the sides. So right now, I know one side in the big triangle is 12. Can you help me match it up with whatever side it corresponds to in the small triangle? Is it 7 or is it 5? Do I guess? No. How am I going to figure out what 12 matches up with? I'm going to use that beautiful statement at the top they gave me. 12 is side AC. So everyone look where A and C are. A, C. What's it match up with in the other triangle? DN. C, which is 7. So I know 12 and 7 match up just by the statement alone. So that means their perimeters are also in that ratio, 30 and x. Whatever the side ratio is, it's the same as the perimeter ratio. And then I get something nice and neat I could cross multiply with. 12x equals 210. We'll grab our calcs, divide by 12. What are we looking at? 17.5 for the perimeter of the small triangle. All good? Questions, comments, concerns? All right, I think the next one I want to go to is number 5. Number 5. Solve this for x, leave your answer in simplest radical form. Hey, whoa, before we start, I think I basically told you what's going to happen by saying leave your answer in simplest radical form. Sooner or later, what's getting busted out in this problem? If I need my answer in simplest radical form. Quadratic formula. All right, because there's no way I do factoring and I'm left with radicals. So I know in my head, eventually when the time comes, and it's going to come quick, I'm going to have to use quadratic formula. And you're welcome on this one. You don't even have to cross multiply, set it equal to 0, it's done. What's the A value? 2. B. -5. C. +1. And Eva asked before, I will give you this tomorrow if you need it. I will provide it. You just got to know how to use it. What's going in for -B? 5. -5 gives you 5. Plus or minus. Nobody in this room should be trying to do this in their head. Or plugging in B, A, and C on your paper. Do it all in your calculator. Let's review again. Let's review the store key. Store. 2. You got your store key right to the left of 1. Store it in. I don't know why I just did that. Store it in for A, alpha math. What's my B value? -5. Make sure you hit the negative sign, not the subtraction key. -5, store that bad boy in for B. And then +1, store it in for C. And I'm going to let the calculator do the work. B squared minus 4AC. And I should end up with 17 underneath the radical. Yeah, everybody else, 17, confirmed. Let the calculator do it. Now, could a lot of you probably get 17 doing it yourself on your hand, by hand? Sure. I just worry a little bit with some stuff. 17. All over, what's going in the denominator? I got 2 A's there. 2 times 2, 4. All good so far. All right, now let's see. Anybody want to try to break down 17? Because that's your next step. Try to break down the radical you have. Can you find a perfect square that goes into 17? I don't think so. There's no perfect square that goes in evenly. So if you cannot break down the radical, that's what we considered simplest form then. If you can break it down, keep going. But if you can't, that's as simplified as we get right there. Now, throughout this unit, we at the end we have to check if we have to reject or not. Right? We always have to check if we need to reject an answer, even with quadratic formula, because we get the plus and the minus answer. Why don't I even need to worry at all about rejecting here? Not at all. Why is there no need, no worry to reject at all in this problem? Mahmood? Anybody see a diagram? So there's not even a possibility to have negative sides, right? So right away, oh, I don't even have a diagram, we're done. I can accept both answers. Who cares if the other one's negative? There's no diagram. There's no negative sides possible. So I'm done. I am going to accept both answers here. No diagram, it's an automatic accepting of both. All good? One more, and that's the next one, because I want to factor with you too. Not just do quadratic formula, I want to factor with you. Okay, B, C, and D, E are parallel. That tells me right away the triangles are similar. We talked about that. That gives you corresponding angles, angle, angle. So they're similar. AB is X. AC is 3. BD is X minus 2. CE is X minus 4. If the triangles are similar, their sides are in proportion. Can you not as a group, can you right now come up with your own proportion? I'll come up with mine, and we'll see if we cross multiply the same things here. Pleasure. So go ahead and make up your own proportion, what you think is correct. Full sides only. Nobody should be putting X minus 2 or X minus 4 in their proportion. You need full sides only, not partial sides. All right, let me build mine real quick. Don't worry if it doesn't match mine, but ready? Are you cross multiplying X and X minus 1? And are you cross multiplying X3 and 2X minus 2? I don't care how you set it up. That's what we should be cross multiplying. Always keep in mind, you should never cross multiply sides from the same triangle. Never. All right, let's go to work then. I get X squared minus X on one side, 6X minus 6 on the other. Can't factor unless one side's equal to 0. This is nothing new for us, this unit. So keep your X squared positive. I should end up with a minus 7X in the middle and a positive 6 at the end. Now, I am not going to complain or say anything tomorrow if you decide to use quadratic formula at this point. It's fine. I am going to say something now, though, being in an honors class. We could find two numbers that multiply to 6 and add to negative 7 at this point. Tomorrow, you want to use quadratic formula and get the correct answer. I'm not going to say anything. But right now, we should be able to factor this. What do you got for numbers, Paul?
Negative 6 and negative 1.
Negative 6, negative 1. So how about our two possible answers now? X equals positive 6. X equals positive 1. I understand because I'm part of the problem. Nobody sees a negative answer. You're not even going to bother to see if you need to reject or not. Because usually the only time rejection comes into your mind is if you get a negative answer. I still got a problem with one of those. You better let me know what my problem is. I get it. You don't see a negative answer, so maybe you don't even think about rejection. But Lauren, what's the problem with one of them?
You have to subtract 4 and 2 from 9.
Which answer is a problem?
1.
If I take X equals 1 and plug it in right here for BD, I got a problem. That's a negative side. 6 is fine, right? The answer is 6. That's no big deal. But yeah, sorry. 1's not, even though it's positive, I'm still rejecting it because it gives me a negative sideline. So be careful. Just don't assume positive equals accept. X equals 6, only answer. Anything you'd like to ask? Okay, you can keep grinding on the packet. Or get a textbook or your online textbook and get going there. Your call. All right, let's get after it. 20 minutes, 23 minutes. Work with people in your group, talk it over. It's up to you. If you get stuck, call